Okay, welcome back. We're talking about restoring a safe climate. It's actually possible. I'm John Foreman, and here with Herb Simmons again for part 3 of our discussion. In the earlier discussions, which I would definitely encourage you watch, although you can watch this now and still be informed, but it helps set a great background for this. We talked about, Herb introduced the climate triad, which is, in fact, he argues, the most equitable solution to addressing the horrific climate crisis. Talk about the standard thing everybody mentions, which is emissions reduction. And then we talked about 2 other important things, very important to actually do direct global climate cooling to short-term restore a safe climate. And then we mentioned briefly about carbon dioxide, CO2, or GHG, greenhouse gas removal. And that's going to be the focus of today's discussion, among other things regarding policy and equity around that. So that said, take it away, Herb, and tell us why we should remove greenhouse gases, GHG, from the atmosphere.
Hey, thanks, John. And it's happy to be back for part 3. And for those of you who watched part 1 and part 2 and didn't give up, or back for part 3, delighted to see or hear you again and have you listen to what at least I feel is a maybe a bit of a controversial, but I think important perspective that I hope climate leaders and activists everywhere will at least give consideration to. And that's really my purpose. And I very much appreciate that you provided me this opportunity. So with that, as I mentioned in the earlier discussions, there's, I think, a fundamental misconception as to what the driving forces are for the change in atmospheric climate. And just briefly to say that the increased heat, which drives all of the extreme weather and the extinctions and the ice melts and the forest diebacks and all the rest of it, is a function of the amount of carbon dioxide and other greenhouse gases in the atmosphere above the historic norms that provided us with this kind of Goldilocks atmosphere, not too hot and not too cold. And
when you say historic, you mean way back, as in millions of years ago, correct?
Well, I mean, the atmosphere has really varied. The concentrations of gases over the millions of years dramatically as Earth has gone through ice ages and extinctions and so forth. But in the past 10,000 years or so, we've had the so-called Holocene era, which it really is a kind of Goldilocks era, where by and large, with certain exceptions, humans and other species have thrived until literally just now, the past decade or so, where that's changing. And the reason they have is because the level of greenhouse gases, which controls how much heat remains in the atmosphere versus going out into space, was a kind of the right thermostat, if you will. It was consistent with our needs, our physiological functions, and consistent with a stable ecology. So you didn't have ice melting, or you didn't have forest burning. I mean, you had some of it, but not anything that got out of hand. And so what's happened is that as we add additional greenhouse gases above the ability of the Earth's atmosphere and oceans and land to absorb that CO2, then the blanket, as I talked about before, and the blanket is a kind of metaphor, if you will, but I think it's a very accurate one. The blanket that covers the Earth has thickened and thickened really since the beginning of the Industrial Revolution, when we started burning large quantities of coal, to the point where it's gotten so thick that it traps the heat. The same way on a spring night, if you put one blanket on and it's just right, and then somebody, like every hour you had some kind of mechanical device, or your bed partner or something said, "Now I insist you put another blanket on." And at 3 a.m. on here, I want a third blanket, and you're sweating and you're sweating and you're sweating. And, the room is just getting hotter. You're just getting hotter as each blanket goes on. And it's a kind of ridiculously simple metaphor, but it's pretty accurate.
So the blanket is the concentration of CO2, but GHG in the atmosphere, correct? And I thought you did say that is way higher. I know it sounds like it's ebbed and flowed throughout history, but is it not way higher than it has been in millions of years? I guess I'm trying to clarify that
I don't
fact.
know if it's millions of years, but it's way higher than it's been
Or the
in,
acceleration of, maybe it was the acceleration of the
well,
concentration
it's
of
both.
greenhouse gases.
The absolute level is 50% higher than it was in the 19th century. I mean, you don't have to go back millions of years. That's what, and from what I understand, from what scientists are saying, they're not aware that it's ever increased this rapidly. It may have gotten to higher levels, but the increase where it's literally every year that blanket is thickening by about
So
a
that's where we
quarter.
get to the critical point, right? Because the acceleration is happening so fast. Like historically, you could look at the record, you could see when ice melts occurred, you could tell from certain geological events by looking at ice cores and so forth, what the
Right.
concentration of CO2 was in the atmosphere, like what may have happened. But so far as we know, nothing, the level of GHG or CO2 has not risen so quickly, and that introduces a level of unpredictability into what can happen.
That's right. It's both. It's the overall level and how quickly it's gotten there, much quicker than human society and most all animals and plants have the ability to adapt or change. Their behavior, their physiology, so that they can survive in higher temperatures. I mean, when I wrote my book, A Climate Vocabulary of the Future, some of the research I did suggested that even this was 5 or 6 years ago, that plants and animals were migrating north in the northern hemisphere and south in the southern hemisphere to cooler regions as much as 10 or 15 miles a year, in the oceans and on land, if they could. Now it's harder for a plant to migrate, not impossible. The seeds can be carried to a more, or, taken by humans or animals to a more northern latitude or a higher latitude, which is cooler. So we've all been in this sort of race to adapt, and for humans, it may take the form of, having stronger air conditioning, or buildings that are better designed, and for, clothing that wicks away humidity faster, whatever it may be. In any case, that's how we're adapting. But the problem is that as long as that thick blanket is up there, and the point I want to reiterate from the last discussion we had is, if you think about it, don't take my word for it, but think about it, all 98% of the emphasis of the entire climate community, activists, scientists, policymakers, ordinary people, is saying we have to slow down or reduce what we put into the atmosphere. But what we put in the atmosphere isn't affecting does not have the ability to make the blanket, more porous or smaller or less thick or thinner. It only keeps it from getting thicker a little bit. So in other words, it does nothing to solve the climate change problem. All it does is slowing down the rate in which it's getting worse. And of course, that hasn't happened. I mean, that's the other thing. 30 years of, worldwide conferences and trillions of dollars of expenditures and, every marches and protests and meetings and everything else. And atmospheric CO2 either continues to go up, or in the best years, it's just leveled off. So we haven't even achieved that. We haven't even achieved the ability to reduce the rate of increase of the problem, much less getting back to a more livable atmosphere. And so that's the context. So essentially, CO2 removal is like saying, we want to start removing the blanket. Not all of it, but enough of it so that we're not sweating at night. I mean, again, simple as that. In terms of numbers, in the 19th century, the concentration of CO2 was about 280 parts per million molecules, or percentages of the atmosphere, of the air. Today, it's 420. So it's increased by 140, which is exactly 50% since the 19th century. I mean, that's
And we've zoomed past 350.org's goal of keeping things at 350. We're way well beyond that.
that's right. And it's interesting because, and I don't, well, maybe I do mean this as a criticism of 350, because you look at what they're doing, you even go to the national website and you look, I looked in vain to see where they talked about what their plan is to get back to 350, which is their name.
Right. But we should talk about that, I think, in another episode, as to what's the actual strategy for the activism and climate and business community and all that stuff to achieve these goals. So anyway, so getting back to where we were. So we've got the climate triad. We've got this extraordinarily dangerous situation where we've got heating that's happening now, that's extraordinarily dangerous now. It's the climate scientists are saying, we keep hearing, well, it's worse than we expected. The oceans are warming faster than we expected. We're seeing extremes in temperature and perhaps fires and drought and weather systems that are more extreme than normal, which is extremely disturbing. And I guess it gets directly back to your point about that, or maybe we haven't seen GHG accelerating so quickly in such a short time, which is part of why this is so dangerous, and we really need to take the climate triad approach. But that said, so the direct cooling is really to address the current issue of the fact that we're already in an unsafe climate. And we all know we need to do emissions removal, because that just keeps making the blanket bigger and making global heating worse. And then there's the CO2 or GHG removal, which you articulate as being a longer term solution, but necessary to, in the very long run, get the blanket back down to what it used to be, so that we have this stasis that's healthy for humanity. How do we do that, I guess, is
Okay, good question. Let me first say that a number of examples that I'm going to briefly discuss have to be looked at in the context that no government in the world up until now, and it's just starting to happen in the US and maybe other places, literally this very year, has made it a policy to encourage and support the removal of greenhouse gases from the atmosphere. So therefore, if people say, after I present this, or if they read about the techniques and they say, I don't think any of them will work, well, that doesn't mean that it can't be done. It just means that governments, that in other words, there's no market, there's no incentive for you or I as a private individual, except altruism, which carries us so far, to do the research and come up with a proposal to do it if we're not going to be supported or rewarded. And the point being that if and when governments actually say this is a policy objective, the way they did 20 years ago, if I could, John, if you look back 20, 25 years ago at the cost of solar and wind, the reduction in the cost has been multiple times faster than any analyst predicted. And a lot of that came about because governments, interestingly, Germany was the first to make a major policy to support it and subsidize it. And that led to, much more research and development and marketing and manufacturing. And today we have solar and wind that are at the cost, or if not less than the cost, of fossil fuels. So if something similar could happen, but it won't happen until governments give the green light to make it happen. So I just want to say that first. Policy is critical. So what are the general techniques? Well, there's lots of different ways to think about them, or not lots, but several. One is to what degree they're sort of quote unquote natural, and that's a tricky word, versus more industrial or engineered or technological. Another is whether they're based on the land or on the ocean. So let me just go through a couple of them. All of these are sort of in their early stages of analysis and field testing, if you will, and deployment. And we're trying to learn from actually deploying them what the impact will be, positive and negative. So there's a whole realm of what are called natural climate solutions. And this basically involves using the photosynthesis, which is basically a function of plants and green life taking CO2 out of the atmosphere and using it as a raw material to grow themselves and live, and then respiring oxygen back into the atmosphere for us to grow and live.
Well,
And
if I decide, what are the major categories? The one I'm familiar with the most is basically just machines that essentially run on hopefully clean energy, which is critical. And they suck out CO2 from the atmosphere and have some way of storing it somewhere. That's one category. It sounds like it's just mechanical, right? And then you're talking about biological. Are there other major categories of potential ways to
well,
do?
there's some that are sort of maybe hybrids or what might be called geological. So I'll mention there. But the biological has, I think it's the kind of thing that appeals to virtually everybody. It's the old thing about, I see it all the time on Twitter when somebody suggests a mechanical means of taking CO2 out of the atmosphere, and then somebody will give a tweet and say, well, the best way to take things out of atmosphere is plant a tree. You don't need to invent a bunch of machines. The problem with that, John, is that trees die. They don't last that long, and when they die, all the CO2 or much of it that they sucked in goes back to the atmosphere again. And essentially, if you think about it, the CO2 by and large that we're putting in the atmosphere comes not from, some of it comes from plants and burning wood and so forth, but most of it comes from fossils that took millions of years to form, and basically, for the fossil fuels that are made up of dead plants and animals that took thousands of, or more than thousands of years to be developed and created, and we're putting them in the atmosphere, and you can't counterbalance that by taking trees or soil or plants or whatever that are only around for a few years. But nonetheless, those are things that have great co-benefits anyway. Planting trees, enhancing soils, doing regenerative agriculture, restoring mangroves, wetlands, new sorts of farming, things that are like, it's called silvopasture, where you have animals and trees together, which leads to greater CO2 absorption. These are all very promising techniques. And just before I wrap up on that, the problems with them are, number one, permanence, as I just said, because you got to keep the stuff out of the atmosphere for a long time, not for 50 years or 40 years, and then have it go back. That doesn't really solve much of a problem. Second thing is, how do you measure it? And how much does it cost to measure it? If you're going to say to a farmer, real practical stuff, how do you know how much CO2 you've taken out, in a cheap and accurate way? And these are things that are being researched and tried out all over the world right now, but there are no definitive solutions yet.
Let me ask you a little bit about that. So, like, that reminds me of a book called Project Drawdown, which outlines a number of scientists and researchers looked at individual ways like the ones you're talking about, except many, many different ones. And they tried to measure, how much CO2 can we draw down, how much emissions can we cut. So, it does sound like there's a lot of different ways that should be done, right? It's a sort of a, how can I say that? Are you saying that we shouldn't try to attack like all those different natural approaches for drawing things down, like regenerative agriculture and planting specific types of plants and silvopasture and so forth and so on? Are you saying we should focus more on, actual more specific engineered ways to remove GHG from the atmosphere? Whoa, I think I lost you, Herb. Okay, we're going to pause for a moment and get back when we're having some technical difficulties here. Okay, we had a little technical difficulty. So you were just mentioning, Herb, that a lot of these natural solutions like planting trees and silvopasture and various agricultural techniques, they just don't cut it as far as like long run removing CO2 and GHG from the atmosphere. Is that what your position is, or did I understand that correctly?
Yeah, no, essentially that's the case. There's some interesting, there was a paper just written arguing that they still may be worthwhile because even if they can provide temporary greenhouse gas reductions for say 50 years, that could also serve as a kind of a transition, because the key thing we have to do is to keep temperatures from rising in the short run, because that can activate, as I talked in previous sessions, all these tipping points that lead
Right.
to a point of no return.
And let's
So-
just talk about that for 1 second, because that's really, I struggle to explain why we're in such dire straits. But we need to avoid the tipping points, and we're not quite sure when we could cross that threshold. And is that correct? I mean, we may have even crossed them already.
Yeah, I mean, in some ways we have clearly crossed them. It's a question of whether you can sort of reverse the crossing, if you will. I mean, and that is certainly up for debate. But when you look at the fact that, as I may have talked about earlier, that from what I've seen, the vast majority of the scientific studies that come out that look at the ecosystems that could tip, they almost always say, my goodness, what we've found is changes, negative changes, worsening, happening years, if not decades, than we had expected, but years sooner, faster, worse. And so do we really want to bet the future of life on Earth that these worse impacts won't continue to happen faster than expected? I mean,
We
to me,
absolutely
it's
not want to.
and I think that's a lot of the core of the argument that my colleagues and I and others more and more are making, that the likelihood that we will be able to avoid utter, I don't want to say extinction, but I use the word decimation rather than extinction. There may always be some small number of human beings living a very primitive, unpleasant life somewhere. But the likelihood that we can avoid that kind of massive destabilization, I think, is not something you want to bet on.
Sure as hell don't want to. So anyway, so the climate triad, right? We've got to get the emissions cut so that we don't add to the blanket. We've got to deal with, the technology is not there to remove GHG from the atmosphere right now, like starting and just doing it. So we have to do the direct cooling so that we can figure out how to cost effectively remove GHG and carbon from the atmosphere. So we were talking about
if I could just interrupt you there. You said a kind of magic term that I want to push back on a little bit, and that is,
okay.
you said cost effectively. And while cost is not irrelevant, and it shouldn't be, what's the cost of saving the human species and all other species? And I think that's a trap. That's the kind of neoliberal trap that we all are subject to some degree. And I see it all the time. Well, until we can get greenhouse gas removal under $100 a ton, then we can't really do it. Like FDR in World War II didn't say to his army, until you can get the cost of a B-1 bomber down, we're not going to try to defeat Hitler. You know what I mean?
So are there techniques now that we could apply and start to do this immediately then? If let's just say that, okay, we could actually build these solutions, we can get it going. There's some, however it works, federal subsidies, or it's just a totally public enterprise managed by the government. Do we actually have the technology to get this moving ASAP, or is it more research mode?
Well, I think we're somewhere between research and ASAP. We're in the kind of field testing of a number of these approaches, both natural and machines and so forth, where they're at small scale. We're testing them. We're measuring how much greenhouse gas they take, how much energy they use, what the side effects are. But again, as I said earlier on when we started, and this gets to what your question is right now, I mean, what I would propose the government do, and ideally it would be a number of governments working together, not just one government, though obviously the US, they did, or China, if they did it by themselves, would have an enormous impact. But let's say a number of the EU countries and the US announced in 3 months a kind of what's often called a tender, in other words, a request for proposals, which governments do all the time. I mean, it's how they do their business mostly. And they said, we're going to put out a request for proposals to remove a gigaton, which is 1 trillion tons of CO2 from the atmosphere. And we will give bidders, whoever you are, universities, companies, consortium, 3 people on the street, well, whomever, you have 3 months or 6 months or some period of time to put a proposal into us. And what we will do is we'll guarantee we'll pay for it and we'll get you the permits, et cetera, et cetera. And that would unleash the creative impulses of a good chunk of the human race. And that's what I would love to see. And then we'd see, in maybe that first period of time, it might take a year until you do the RFP and the request for proposal, get them back, evaluate them, give the contracts out. And then let's say after 1 year, you review the winners of the contracts and you see, what have we learned? How much have they accomplished? Do we need to go to other techniques? Maybe you do a round 2 then, because we don't know. It may be that after a few years, we'll find there are technical issues or side effects or too much energy, and that none of these techniques really can do the job. I think that's unlikely, but I don't think anybody can guarantee that it'll work now. But what I can say is that no one should be saying this won't work or can't work until we try. That's basically what my group is all about, is saying we've got a triad of approaches, only one of the 3 of which we're doing now, the emission reductions, and we've got to try the other 2 right away as objectively and systematically as we can, and then evaluate the results.
And for those that may not have caught it in the previous discussions, what's the website of your group and the name of the group?
It's Healthy Planet Action, one word, healthyplanetaction.org.
Okay, so they can go to healthyplanetaction.org to learn more, presumably. And
yeah, it's a brand new website. We'll be populating it more, but it definitely has some good materials, and we'll be adding in the coming months.
Okay, so it sounds like, just in brief, you're convinced that GHG CO2 removal can work. I know I've heard at least of one mechanical project that's demonstrated the work. There are things that work now, but obviously more research needs to be done. But your group is convinced that it can work?
Well, I think we're convinced it's highly likely to work, but I think there's also the question of what does work mean. I want to go back to the issue of, a lot of people are saying if it can't be done at X dollars, then we shouldn't do it. To me, that's completely absurd. So maybe it works, but it'll take twice as much in the way of resources as some would like. Does that mean it's not working? No, it just means that a higher proportion of the world's resources need to go into doing this. And that's a value judgment. God forbid, we may have to spend as many resources as we spend on, hairspray or dog food or something like that, or deodorant.
Yeah.
I'm only being half facetious when I say
you make a good point, though. So there are viable prototypes and pilots that have been done to demonstrate that you can actually remove CO2 from the atmosphere.
Oh yeah, I don't think there's any doubt that you can remove it. The question is at what scale, how quickly, and how many resources does it take, and are there dangerous or at least unpleasant side effects?
Okay, so that gets us to the question of back to the climate triad. We know about emissions reduction. We talked in the previous episodes about direct cooling, which is critical since we can't remove the blanket quickly, in part because these technologies, we need to research and figure out how to make the CO2 GHG removal technologies better. We've got to cool things down now to restore safe climate, to buy us some time. So the question is, if these things, direct cooling and GHG CO2 removal, are so great, why isn't it happening? And maybe you already answered that, but I'm going to ask it again.
Well, and of course, that goes to the heart of the problem. I think there are a couple ways to respond to that question. One is that there was I wouldn't say an optimism, but there was some level of optimism that as long as we accelerated our progress on emission reductions, that would do the trick at an acceptable level of environmental and climate damage. And there's still some people that believe that. And and that, again, it's not a right or wrong. To some people, and countries having hundreds of millions of people, get flooded out every year is an acceptable cost. There's no right or wrong answer to how much misery is reasonable. So that's one reason.
Preferably zero, right?
Well, you never can get this. I mean, even before climate change, you had natural disasters killing people all the time. So it's not as if,
Oh yeah.
we've had a totally benign environment or climate. But the second reason is I think there's kind of a fear. It's called the moral hazard, and that is, well, if we start focusing on saying that we can solve the problem by removing carbon from the atmosphere and or directly cooling through various techniques, then people will give up trying to reduce emissions and will be worse off than before. And that's an argument that I completely reject. I think it may have had some validity 25 years ago, but we don't have the luxury of saying, because of some concern about the psychology, essentially, it's like, well, if we do this, people may behave that way, that we wouldn't undertake a serious analysis of a technique that could save billions of lives or millions of lives. But that's a second reason. And again, there are others who've said it's too costly, it would take too long, but I think a lot of it, John, and it's impossible to measure, but is kind of the I don't know the best way to describe it, but it's kind of like a sunk environment, a sunk intellectual belief, like a sunk cost, in that
it's an intellectual habit. It's a habit.
Exactly.
We have ways of viewing the world that are habitual, and it's hard to change. We all get stuck at them. It can be hard to be presented with new information and see it for what it is and change your mind. And people are emotionally attached to what they believe in passionately. It's a sociological, psychological problem. No,
you said it much better than I did. But I mean, so right? In other words, you have a climate scientist or a climate diplomat for 30 years saying emission reductions, and for them to now say, well, emission reductions haven't worked and we have to do these other things, is a leap. And part of the problem then has to do with the sociology of science and funding, because if these key leaders, key scientists, academicians, diplomats, et cetera, public policy people are so invested in the what I call ERA, emission reduction alone model, then if I want to see if I can get a grant to try out a carbon removal approach, who's going to fund me? That's why it's so critical to get the government.
We should have a darn agency focused exclusively on that, or at least most of the budgetary research funds for like the National Science Foundation or the Defense Advanced Research Projects Agency. Like the biggest threat we have is climate crisis. So let's pause here. We're getting to the point where we wanted to take a break. Is there anything you wanted to cover about why direct cooling and GHG is not happening before we pause for a moment?
I think there's 3 or 4 examples I've given or capture the essence of it. And lots more reasons we could talk a lot more, but basically it comes down to those things. There's kind of an intellectual rigidity. There's concern about costs, concern about side effects, concern about moral hazard, and all the issues that related to those 4 things.
And can you talk a little bit, actually, before we break, about why is there such intense opposition to the direct cooling piece, or should we go into that after the break?
Well, I think I can touch on it briefly now, and that is, again, it's only my surmise, because even if people say why they're so strongly against it, it may not be truly why they're against it. They may not even know themselves. But I think if you go deeper down, I think a lot of it happens to be particularly among people on the left, an anti-technological perspective that has deepened and deepened with good reason. I mean, in other words, it's not an irrational, sort of attitude to have. And what I often hear, and it's difficult for me not to grit my teeth when I hear it, because I think it's so wrong, is the fact that people say, well, we can't solve the problem with the same mindset that got us in the problem. And to me, like, who knows what that means? But I think when people say that, that means, well, the problem is that, we were burning all these coal and creating this technological society. So therefore we can't use technology to solve the problem, like blocking the sun or something. But I mean, I think that's at the heart of a lot of the opposition. And it's a distrust of the people who would be employing the technology, particularly, well, people on the left and the right, the distrust of the elites, that they may have different, ways they manifest that they clearly do, but on the left and the right, saying, we don't trust the elites that run our government and our institutions to do this in a way that will benefit us. They're going to do it to make money or to accumulate power or whatever. And so instead of sort of putting those concerns in the background and saying, let me be as objective as I can and think through, do we really, is this necessary? And if it is necessary or likely to be necessary, and at least has a chance of working, then the next question would be, well, then how do I make sure that it's democratically controlled enough so that we don't have this problem of the elites misusing it, or the scientists coming up with kinds of, technologies that turn out to be disasters years later and when it's too late, as opposed to saying, we don't even want, I mean, literally, there are people over the world marching saying, we don't even want you to research this. That's how fearful they are. And every time I see that, it's terribly disappointing, because if you can't start a dialogue about, should we think about doing this or that, when people don't even want to entertain the possibility of the whole field. And to me, the last thing I'll say before the break is that is a level of climate denial that is every bit as destructive. I don't mean to question the motives of people doing it in their good faith, but the consequences of that is every bit as destructive as that of the blatant climate denial and the propaganda put out by the oil companies and whatever, in that it keeps us from at least objectively looking at what could be solutions that could save the lives of untold numbers of people.
This problem is so gigantic and global that we have to be as objective and thoughtful as in order to actually tackle it. So on that note, let's pause for a second. We'll be right back. Okay, we're back. So we're going to wrap up this episode. It was an excellent discussion about talking about the parts of the climate triad you may not have heard before, direct global cooling, and especially GHG and CO2 removal. So what we want to go into next are why this is an equitable solution, how it can be an equitable solution, and then policy. How do we actually make this happen? How can we make it at the federal, state, and local level? What do we actually need to do? If you have any comments or questions, please post them in the chat or look in the description of if you're catching this on the podcast, look in the description. You can either post a Facebook question there, or you can write me on an email that I'll post there. And Herb, is there anything else you wanted to say to wrap up before we?
No, I just want to emphasize what you just said, John, and that is that I would love the opportunity to respond to your comments and questions at the next session. So I really encourage you, particularly if you're skeptical, because I recognize that this is maybe new to a lot of people and against what they've heard from other sources. So I think that's often the most productive thing to do. So please contact John in the ways he suggested, and we'll make sure to be able to respond fully to your questions and comments next time.
All right, with that, we sign off. Thanks very much, Herb.
Thank you, John.